Welcome everybody, and thanks for joining the VOLTHA 2.7 webinar for today. Um, just a little bit of a housekeeping while we wait for a few more folks to join. As you know, there is a Q&A button at the bottom of your screen while my presentation is up. If at any time you have a question, you can type it in there. Most of our questions will be answered at the end of the meeting, where I will leave an extended period of time for questions to be discussed within the group. And so please ask them there, and I'll take them at the end of the meeting. So thanks for joining. I am Andrea Campanella, a member of technical staff at ONF and currently part of the VOLTHA and SIBA team. And today I will present the 2.7 release, which we just had at the end of March. So just an outline of the talk we're going to have today. We're just going to talk a little bit about the SIBA 2.0 and the VOLTHA architecture and the current project state. We're going to discuss a little bit on the operators deployments and feedback loop that we have with them. Then we're going to talk about specifics of the 2.7 release, in particular the service software upgrade, the ONU software upgrade, alarms and performance measurements, the charts for VOLTHA Infra and VOLTHA Stack, the PPPoE, and the testing that we have done. Finally, we'll talk about the VOLTHA 2.8 roadmap and some Q&A at the end, as I mentioned. So just as a refresher for anybody who isn't familiar with it, VOLTHA is part of what we call SIBA, Software-Enabled Broadband Access, which is a reference design from the Open Networking Foundation, from us, that defines SIBA as a lightweight platform for development of solution for carrier broadband access. And in particular, we just released RD 2.0, a reference design 2.0 for SIBA. That includes a disaggregated border network gateway specification, per VOLTHA stack modeling, detailed northbound APIs, and device management API. It is released and open for everybody to access. And if you want more information about it, you can see it on the webinar I did in conjunction with Turk Telecom and Deutsche Telekom a couple of weeks ago, and you can find a lot more information in there. And a huge thanks to these group of companies that worked tirelessly to put out a very good specification for SIBA that then gets translated into what we're going to talk about today. So just as a reminder, the example architecture of SIBA, we start with the RG and the ONU on the PON network on one side, and on the other side, we have the BNG and the core. In the middle, we have some white box OLTs and some white box switches that are, those act as the BNG user plane. And there are some servers for compute power. Then we have all our software, which is deployed in Kubernetes via Helm and is composed of Docker images. Part of that is VOLTHA, then part of it is Stratum. Then they're both controlled by ONOS, the SDN controller, via OpenFlow MP4 runtime GNMI OpenConfig. ONOS has a set of applications. We'll talk about more of those later. And all of it is managed by NEM. That has the capability to interact with the operator OSS BSS or to own up through a local adapter. In particular, today we will focus on ONOS and VOLTHA. So just where we are with the VOLTHA project. If some of you remember, last time we spoke about the 2.6 release, we talked about what achievements were made with the 2.6 release, and this is what we have right now before going into 2.7 release. So we have a common control and management platform for PON networks. We are capable of handling different brands of OLTs and ONUs through different OLT adapters and ONU adapters. that connect with the core to Kafka, and the core is then exposed either via gRPC or to the OpenFlow agent to ONOS. And all the data is then stored in a TCD. We are capable of handling multiple types of services different per operator, and also workflows. We have a device management interface to manage not PON related specs, not traffic related elements. And we are capable of having multi-stack support, meaning multiple stacks that are deployed on the same infrastructure composed of Kafka, etcd, and ONOS. And we also have now, as of 2.6, the OpenONU Go rewritten, the OpenONU rewritten in Go, and we're capable of reaching with 10 stacks, 10,240 subscribers on the same infrastructure. If you want more details about specifics of what was reached in 2.6, or for example, the multi-stack improvements, you can go and watch the VOLTHA 2.6 webinar, which is linked here, or read the VOLTHA 2.6 release notes. The key element and very important part that I need to right now focus on is that VOLTHA is now in production with live customers of both Deutsche Telekom and Turk Telekom, meaning that there are live customers connected with their ONU and their RG to the network that is fully managed by VOLTHA and their subscriber lines are provisioned by VOLTHA, and everything is managed and controlled by the combination of VOLTHA and ONOS for each of those subscribers. If you want more information, you can find it in these links that outline more in detail the deployments of Deutsche Telekom and Turk Telekom. This is a key achievement. It's a major success for the project. It's a huge success for the community, for ONF, and for everybody that has worked with the group here. But what does this enable us? The key point is that production deployments of both Deutsche Telekom and Turk Telekom strongly interact with the ONF and the VOLTHA community. They're not just something that live there and they're deployed, okay, fine, we're done. So the first thing is that through these deployments, the operators have a lot of lessons learned. They come up with new requirements, especially deployment requirements. Oh, I would like to analyze this. I would like to see this point. And also they find bugs and scale issues. No software is perfect. So they take these from their production deployments and their analysis, and they feed them to the ONF and the VOLTHA community. In turn, the ONF and the VOLTHA community put in new features, bug fixes, release new releases, put out new releases, as is 2.7, for example, with the information that was given by the service provider. Implementation, analysis and implementation was done by the ONF and the community. And these new features, these bug fixes, these elements that go and solve some of the issues and requirements that the service provider came up with are put into, again, in the new release. So what does this help? This incredibly helps the product quality. So VOLTHA is incredibly growing in quality and feature richness, and also grows the project maturity because you're seeing less bugs, you're having less scale issues, you're growing in capability of observing the system, observing the data and the functionality that the status of the system that is in production. So based on the production deployments, one of the key requirements that the operator had for 2.7 was software update. The idea was that we need to achieve software update while in service. So we cannot turn off the data path of a customer for minor bug fixes to the platform. Major version upgrades, that is done to a maintenance window and will bring down the data path. But minor software bug fixes should not take out the data path of a subscriber, of any subscriber in the network. So that's what we call in-service software upgrade. And how do we define a minor version update? It means that there are no API changes and that the data format of anything that is stored in the TCD is not changed. And the key requirement was that it was both done for the VOLTHA apps and the VOLTHA components for the software on the VOLTHA system. But also the operators wanted to change the software on the ONUs, because while once an ONU is in the field, you should be able to update the software on it via OMCI, which is the channel of control of the ONU. And the whole goal is really to support bug fixes in live production networks. So let's start with the ONOS apps. So the capability that we introduced in 2.7 was to swap out an ONOS application that has a bug and put in a new version without that bug. So we removed some mandatory inter-application dependency. We separated the API package version from the implementation package, and that enabled restart independently of each other, and distributed all the required state in atomics. So how does that look like? First of all, you find out a bug in an application. Let's take the OLT app on top of ONOS. Then you develop a new version of the app, let's say 4.4.1, and before it was 4.4.0, and you go and deactivate the old app. You uninstall it, and then you install the fixed version OAR from ONOS. And at that point, when you call activate, ONOS will keep the new version of the API on top of everything else. And in all of this time, you don't have impact on the data plane of the user, because removing of the application doesn't affect flows that are existing in ONOS, doesn't affect ports, devices, groups, meters, elements that are required for the data path to be working. We don't change it. So the data path is still working and no other app is actually restarted. So this is on the ONOS apps, and this is valid for all the apps that are automatically deployed within the system. So OLT, AAA, DHCP-L2 relay, SADIS, multicast, IGMP proxy, and Kafka have this capability. A key point is that the VOLTHA components, and not just it, but also the data plane, as I mentioned, perceive no change. VOLTHA doesn't even know about the restart of an ONOS application, which is key. Separations of concern is paramount. Then the second step was actually also having this capability for the VOLTHA components. So in the VOLTHA components, we were already capable of having restarts of the different components without the service impact. Now we just needed to make sure that this was also fine with a change of the version. The implementation was that we needed to check that, again, there was no impact to the system when restarting a component with the changes, and that all the storage needed was in the TCD to enable this restart. The procedure is very simple. You have the OpenONU adapter, let's take that one, that has a bug. Version is 2.7.0. You create a new Docker image with the bug fix 2.7.1, and you just call Helm upgrade of the component. And at that point, Helm automatically deploys on Kubernetes a new pod with the new version of the adapter. And when that is done, it takes up the old one. And the result is that you have the new version in there, and the bug is not there anymore, but still you have the data plane working, and the other VOLTHA components perceive this as a component restart, and there is no data plane impact. So no user sees downtime as a result of this minor software upgrade. So this was a key request from the operators that we met, and we are very proud of this because it means that software in production, in the deployment, in the field, can be bug fixed with no data plane impact in minor version updates. The other big software update that we tackled in 2.7 was the ONU software update. So what does that mean? It means that, again, you have a bug in the image of the ONU that you have in your deployment. This is the physical equipment that stays in the subscriber place, in subscriber apartment, house, or whatever he has the line for. And we are now capable of having the download image API, which takes an image from an HTTP server, which is external to VOLTHA, but in the same cluster, for example, in the same Kubernetes or in the same data center. And it transfers that image to the OpenONU Go adapter. That image is taken from this HTTP server and stored internally to the ONU adapter. Then the operator calls the activate image API. What this does is that it takes the image that we previously downloaded from the HTTP server, breaks it into chunks, and sends it through OMCI data packets through the OLT onto the PON to the ONU. This API automatically downloads, activates, and commits the image on the ONU. During this procedure, the ONU will reboot. And this is perceived from VOLTHA and ONUS as an ONU reboot, the port down event, a port up event. If you want to read more about this capability, I had just shown a few not minor, but just highlights of the procedure. You can go and read this page, which was created by Michael, which is the main author of this functionality, and it highlights the functionality itself, but also some of the drawbacks that we found out in the existing APIs, and we are looking at fixing in 2.8, again, as an incremental approach, because Deutsche Telekom came back and actually said, yes, we like this, but we would like the capability to split the activation and commitment of the image from not do it in one step, but do it in multiple steps. So that capability at the moment with the existing APIs is not really there, but we are now putting it in 2.8. Again, just go through and read this on your time. If you have any more questions, you can send them out to us. Another key feature for deployed services and deployed infrastructure is observability. So we announced alarms and performance measurements for the system. The OpenONU Go had good capabilities, and the Python version had good capabilities, but more were needed and were required as an effort to give more observability to the service providers. So the request for alarm and performance measurement arrives to the VOLTHA core through gRPC. And we have enhanced the performance measurement capability for configuration. We now are capable of supporting grouped configuration of time and timing, especially of these performance measurements. And this configuration, both for the alarms and for the performance measurements, is stored in TCD, so it's persistent, and the NEM has only to do it once. Both the performance measurements and the alarm, after an initial request of getting these from the core, are published to Kafka. So the NEM listens to the Kafka bus and gathers all these performance measurements that he's interested in, but also all the alarms that are generated by the ONU and the OLT. Just as an example, for performance measurement, what we currently support is optical power, uni status, Ethernet bridge history, Ethernet uni history, FEC history, Gemport history. We're looking at adding a few more, and you can find more information in this link. Again, this was provided by Girish, which is the main author of the contributions to the performance measurements. And for the alarms, we just support alarms that are generated through OMCI. So whatever the alarm generated for the ONU, we just send it over Kafka to the operator OSS BSS. And this allows the operator to clearly see what's going on in the data path of their subscribers. Another key addition that we have made in 2.7 is that we wanted to have the deployment be Helm native as much as possible. And we had Helm charts for all the components even before 2.7, but we never had what we called umbrella charts, meaning that during 2.6, we had the split of the infrastructure and the stack, where the infrastructure, again, is Kafka, etcd, and ONOS, and the stack is the OF agent, the VOLTHA core, the ONU adapter, and the OLT adapter. So before we had this script, which was called kind VOLTHA, which deployed VOLTHA and the infrastructure all together. It was a bash script, but we looked at it and said, all of this can be done via Helm, and it would greatly enhance the experience of deploying VOLTHA through Helm instead of doing it via bash script, which is not easily debuggable and prone to error. Instead, if you do it via Helm, it's just deploying Helm charts, and the configuration, you can do it in multiple ways. We have decided to mostly use Kubernetes config maps for configuration. So we have created this VOLTHA infra chart and this VOLTHA stack chart that support all three workflows, so AT&T, Turk Telecom, and Deutsche Telekom, and that support is done via different values.yaml file. And thus, we have removed the kind VOLTHA script. It's still supported, it still works, and nothing prevents you to use it. It's just that going forward for deployments and also for the ONF testing, we will go with the VOLTHA infra and VOLTHA stack charts because they're much simpler and they're just one command instead of the bash script that goes through multiple and waits. Here we are even putting together more and more the deployment of the operators, which already did deploy via Helm entirely, and our type of deployment. As you can see, there is a README here. This outlines everything that you need to know to deploy these, to use these charts, and that is the default way of deploying VOLTHA right now. Last but not least, another major feature that we introduced is PPPoE. So while up until now I've spoken of features that mostly came from operator requirements that are already in production, this PPPoE support was contributed because VOLTHA is always looking ahead at other operators and at other scenarios, and we didn't have PPPoE support. So thanks to Furukawa Electric that contributed this to the community, we now have support for PPPoE intermediate agent. There is a PPPoE app on top of ONOS that is used as a relay of the PPPoE packets. And also, it was introduced PPPoE support across the VOLTHA stack. So in the OF agent, the core, the adapters, and the OpenOLT agent as well. To have the PPPoE support, you must enable the PPPoE intermediate agent on the OLT flow service and install the PPPoE application. And then you can just program the flows using Volt add subscriber. So what happens? On ONOS, you call program flows. That program flows installs a PPPoE trap to controller flow via VOLTHA to the OLT. And that flow is programmed via the cpon tag, pon ctag status information of that subscriber. Then a PPPoE message arrives from the RG. That message is then sent all the way across the stack to ONOS. Then the PPPoE intermediate application inserts the access node information and sends the packet all the way down to the OLT NNI. That packet then goes through the OLT NNI, through the aggregation switch, up to the BNG that does the user authentication by using these access loop information that was inserted by ONOS. So that's the PPPoE support. We never forget also to do scale improvements. We always look at our scale. We always run our scale tests, and we never forget that we need to hit the performance that the operators require, even with the new features. So in 2.7, we introduced validation of the tcont and gemport IDs at scale to make sure that we were not reusing any of the tcont and gemport IDs during our programming, because otherwise that would mean that there will be conflicting flows and conflicting data paths. We also provided bug fixes and improvements for IGMP proxy, multicast, and OLT for the Turk Telecom workflow. Again, if you want, you can see the scale tests at this link. So I've talked about a few features for 2.7. Those were the major features we introduced, but there were a few others that we also put in that are very key, but I would consider a little bit minor to the other ones. And I didn't have the time to dwell into each one of these, but I wanted to highlight them nonetheless. So we made the distinction between the OLT channel disconnection and OLT reboot. So whenever we see a small drop in the gRPC channel between the OpenOLT agent and the OpenOLT adapter, we actually don't assume anymore it's a reboot, but we just wait for a little bit before notifying the core of the reboot. And if the device reconnects back during that time, so there was just a little network blip, and the check is that the device is okay, we just do nothing. So we don't report as a failure here. Then we also introduced AES encryption for gemports, again, going back to deployed systems. They want more security. We introduced the integration of the OLT app with the Mac Learning application for the Turk Telecom workflow. And there was a new application that was submitted by Deutsche Telekom, which is called the OLT topology application that allows to learn about the OLT peers that are not controlled by ONOS. So if the OLT is connected to a switch that is not managed by ONOS, it can learn about its peer, and we can gather this information via an ONOS REST API. There was also a flow error reporting from the adapter to the core and to ONOS that was introduced in 2.7. But not just new features were put in, we always do align features with tests. So there's not a feature that comes into the VOLTHA system that is without the tests. And as key as it was, the software upgrade, we had to put in the tests for it to make sure that it was working as expected with our solution. So we introduced software upgrade tests for the ONOS applications, for the VOLTHA components, and for the ONU software upgrade. We enhanced the ONU adapter restart and reconcile tests. We started working on the performance measurements tests. We introduced OLT reboot versus OLT disconnect tests. We announced the Turk Telecom multicast at scale, and that enabled us to fix some of the bugs and is still enabling us to continue working on that to achieve the full functionality at scale for multicast for Turk Telecom. We introduced enable disable of the PON port entirely for the OLT. And we are now at more than 170 hardware tests nightly. And we also have our scale tests. So if you're interested about the 2.7 view, just go here, and this is the VOLTHA 2.7 test suite. But another feature that we introduced, and it's key for us, is soak testing. So for those of you who don't know what SOAK is testing that involves, uh, again, testing a system with a typical production load over a continuous availability period to validate system behavior under production use. So what did we do at ONF? We took VOLTHA, we deployed it on a cluster, and on that cluster, we also deployed BBSIM for simulation, and we connected a physical OLT with three ONUs to the same cluster. So that cluster was managing two OLTs, 512 ONUs on the simulated one, and three ONUs on the physical one. We don't have the 512 ONUs to test physical hardware at ONF, but we did. But we at least wanted to put in the hardware because, as you guys know, obviously simulated is one, but when you hit the hardware, there's some complicacies and intricacies more than when you just go simulated. So we introduced both this physical and virtual OLT back into the pod. And on that pod, we deployed the 2.7 release of VOLTHA with the code that we put out, setting the log level at warn, and issuing some requests, such as provision subscriber, unprovision subscriber, and restart of the pods. So one time we just restarted our container. And this was successful. We reached 15 days of soak, after which we stopped because we had to do the release, and now it's restarted with the master branch. And we had learned some things, such as that the warn log level was fundamental because at debug level we were issuing too many logs. And we will look at putting in resource constraints for the pods to avoid this too many logs situation. But this is a key element that shows again how VOLTHA is production ready, and it validates what the operators are seeing in production, because we are also seeing sustained load capability of VOLTHA within our lab. The continuous certification program is still going on. We still have the 170 nightly tests that I talked about that certify different hardware. The XGS-PON from EdgeCore, the GPON from EdgeCore. We are again in progress on the Adtran GPON, and other vendors are coming in very soon with their XGS-PON and GPON hardware. We are certifying the Circom FG1000 ONU, the 7712 EdgeCore aggregation switch, and the 6712. If you want to learn more about these, just go to the marketplace. You can find it there. And just to show it to you, just to prove that this is actual hardware that we're talking about, this is the pod that we use in Berlin for certification. On the bottom, the GPON, XGS-PON in here, aggregation switch, the different ONUs, and the Adtran OLT. The key point is that you can join this continuous certification program if you want to get your devices certified with ONF and VOLTHA, because the operator's procurement is then based on this official ONF certification, which is key. So let me do a small recap of what we did accomplish in 2.7. We accomplished in-service software upgrade with minor versions for both VOLTHA and ONOS apps, VOLTHA components and ONOS apps. We achieved ONU software upgrade. We enhanced performance and metrics and alarms, especially on the OpenONU Go. We included PPPoE support with intermediate agent application on ONOS. We improved the scale and made some fixes, especially with the TCONT and GEM ports and the IGMP proxy multicast and OLT. We introduced the VOLTHA infra and VOLTHA stack Helm charts. And we let the soak test go for 15 days, and it was stable with 512 ONUs, 2 OLTs, 1 hardware and 1 simulated. Actually, this should say 515 because it's 512 on the simulated and 3 on the hardware. If you want to learn more and read again a lot more in detail of what I talked about today, you can go to the release notes on the VOLTHA docs.voltha.org website. There you will find a lot more information, and you will find all the versions of the Helm charts and the containers that you will need to deploy VOLTHA 2.7. If you have any questions, you can always ping us and ping me. So, what are we going forward to? VOLTHA 2.8. So VOLTHA 2.8 is going to be released in June. That's the target that we have. And the key features that we're targeting is to finalize the storage and persistency discussions we're having at the TST level. There has been some issues with persistency and the TCD. We're capable of hitting our requirements, but we would like a better solution. So we're looking at possibly using Redis. That's something that we are discussing at the TST level. And we need a resolution on that during 2.8. We want to do some OpenONU enhancements, especially unknown enemies, error handling, traffic descriptors, finish the updates of the ONU software upgrade APIs, and possibly also multi-uni support, and that there's a lot that ties into the OpenONU Go adapter. We want to have a finalized the extension of the OEM capabilities to have on-demand retrieval of the capabilities, and maybe even request based on the capabilities of the ONU, and also some transceiver power, some other information that we want to gather. We want to support all the TCON type selection in the technology profile with both the MEF and ITF bandwidth profile definition. So we have an MEF definition right now. We want to support the ITF bandwidth profile definition. We want to test the Mac learning for Turk Telecom workflow at scale, and possibly support some auto registration of the ONU after deletion and re-come back of the ONU, and multi-uni support for the ONU, because right now we support one uni per ONU. The goal is that if we achieve all of these that I put in here, VOLTHA 2.8 is going to become the first long-term support release. And what does that mean is that we will keep testing it for a longer period of time. That is yet to be decided how long. And we will backport the fixes to it for the same amount of time. And that will give greater confidence to our operators and deployers that VOLTHA is stable enough for a much longer period of time. So a huge thanks to our great community. I don't want to name anybody because everybody has made great contributions to the 2.7 release. A huge thanks to all of those that come to the calls, come to the TST, contribute a patch, even a single line of code. A huge thanks from myself to you, and from the whole ONF team, and from the operators to all of you, because it's so much appreciated, all the work that you put in getting the release out with the features and the functionality. And a huge thanks to our operators, because they trust in us and put energy and resources. And without the contribution here and the community here, all of this would not be possible. So a huge thanks to everybody. Just a few follow-up links: docs.voltha.org. I think I mentioned it before. You can go there, and there's documentation about the VOLTHA project. And you can also ping me at andrea@opennetworking.org. That's my email address. I'm always available there. Or if you have Slack, you can also go and ping me there. So now I see that there are many questions. Let me jump through them and see what I can answer and what we can discuss. So in any case, if I don't come to some of these questions, I will address them later, and you guys will get the slides and the recording of this presentation later by Denise. So don't worry about the slides, you'll get them. They're open source. It's all open source code, and it's open source content. So the first question from Diraj says that today we are an OLT vendor with our own proprietary software. What are the various steps I need to go through to get our OLT platform VOLTA compliant and 2.7 certified? What is the licensing and pricing model for using VOLTA stack on our OLT platforms? So there's a lot of content in there. I could go about for a long time, but let me just give you a few pointers. So licensing and pricing, it's open source software. You can go on GitHub and take this software and download it and play with it. So there's no pricing involved there. In the software stack, you just take it, you can deploy it on your OLTs, you can try it out. No problem. Then, when it comes to certification, there is an involved, there's some money involved. What happens for certification is that you select a platform for certification, and that platform is then sent to us, and that certification comes with a fee. There's some pricing, and depending on your membership status and partnership status, I can send you a pointer. If you go to, so if you go here, you can find more information about this. And given that you're an OLT vendor, what I really think you should start from is the OLT adapter. So in the VOLTA 2.6 webinar, I go into this a little bit more, but the idea is that, sorry if I jump hoops here a little bit, but the idea is that anybody can come in with their own OLT and provide their adapter, which has the same interface to the Kafka bus. So for everybody else in here, it will always see the same interface, and then you just have to do the translation to your own OLT. I hope I answered your question. If you want more information, you want to talk about it, how to get involved, and how to further your collaboration with us, I'm always open to have a call, a one-on-one call, where we can have more interest on there and have a better discussion. So the second one from Lorenzo is, there's an ONU certification process offered by ONF? I think I answered that. Go to the certification program and it's there. We do certify, for example, the Zircom ONU. We also work with other ONUs that are not part of the certification program, but we know they work. So there's a lot of content. And if you are interested specifically in a model, you can reach out to me, and or if you're interested in joining, again, reach out and we can start from there. Okay, so the other question, this is a very good one. I might not have a full answer right now. So the question is, how does VOLTA deal with PON network slicing in case of a carrier neutral network? So that's a very good question. Right now we deploy on carrier network, meaning Deutsche Telekom has its own network, Turk Telekom has its own network, and every other provider that works with us has his own network to deploy. But from our perspective, the PON network, we don't terribly care who owns it. If we're capable of making the subscriber provision call, and that gets sent down to the OLT and the ONU, usually the service provider is then okay with that, meaning that maybe VOLTA is deployed by the owner of this neutral network, and then the different OSS, BSSs interact with this deployed network. If it's just dark fiber that is deployed, and the OLTs and the ONUs are from the vendor, from each operator, then we are also okay working with that. I'm not sure if I answered your question. Maybe I can take that offline a little bit more. So the other question was, how is timing handled by VOLTA, PTP, and SyncE? What are the assumptions made by VOLTA in terms of timing related hardware capabilities to ensure minimum performance requirements are met? It's a very good question. VOLTA per se does not handle PTP or timing. It's handled in the device management interface. So this device management interface has the capability to set a timing protocol that you can use in your device to ensure that it's properly synced. and that is then up to the operator to make sure that the devices are in sync. And the by these API get syncing this device, all Volta is ensured to be in sync, also because the servers that we deploy Volta on will most likely refer to the same PTP server or same timing server. So another question is, would pawns licensing be an app over ONOS? So there's multiple ways of doing it. There was a presentation at the TST some time ago about pawns licensing and how you can do virtual networks. But yeah, I think ideally it would be an app over ONOS that would present slices of OLTs and ONUs differently to the service providers. Yeah, I would say so. The other question is the pawn white box also the VBNG app? So if I am not mistaken, you are referring to this picture. And yes, some of the BNG user plane is partitioned in a full SIBA solution. So not here. In Volta, just plain Volta and ONOS, we usually tend to leave the BNG outside. But in a full SIBA solution, where the BNG is controlled by this system, part of the BNG solution is done in the OLT and part is done in the white box switch. Here mainly is queuing. So QoS is done at the OLT, while the white box switch handles everything else. There is a demo from a year ago, give or take, that showcases particularly the BNG. And if you're interested, just drop me an email. I can point you to a few people at ONF that know a lot more about the BNG demonstration in SIBA that I do. So another good question is, does Volta consider any of the 5G front haul requirements for using XPON for 5G transport? Is support for TSN, network slicing, segment routing in Volta's roadmap? Incredibly long question. Again, I could answer this in fairly good detail. I'm just going to give you a few pointers. So definitely we will consider, we are not right now focusing on 5G front haul requirements, but given that it's a PON network, we can handle it with Volta. Network slicing is not yet considered by Volta. As I said before, it's a one operator network. Segment routing, it's a good point. We don't handle it in Volta. We handle it in the full end-to-end solution. We handle it in what we call Trellis, which is our leaf spine fabric, which is the app that manages the white box switches here in the leaf spine data center fabric or aggregation switches. And that is done through segment routing in the data center. So it will not be done at the white box OLT, in the OLT, it will be done at the data center level. Another question, which says, what about white label bitstream and VULA services over the Volta approach? So to be honest, I have to take this offline. I don't want to give you a half answer right now. I need to take it off, do some thinking about it, and I'll get back to you. Top of my head, there's a few thoughts I have, but I really want to answer properly on this one in an email. So I'll take that offline. If you don't mind, given that it's by an anonymous attendee, I would hope this person could share his email with me or reach out to me so I can answer his question on an email later in time. So another question is on soak tests. Is there any interaction like ONU or OLT disable and reboot? Subscriber provisioning is just a long run test with no interaction on the system. It's a very good question. We actually do have interaction with the system. We do have subscriber provisioning and unprovisioning randomly. We do have pod restart randomly. We have not yet introduced OLT restart and ONU restart. That is a very good point. It's just we haven't had the time to do it. So it's a yes to part of it and it's a no to some other. But we will introduce also ONU reboot and OLT reboot. Another question is how will open BNG initiatives from TIP, ONF, and BBF converge? So interestingly enough, the OpenBNG initiative from TIP and ONF are fairly very closely related. So if you are aware of the TIP submitted BNG device, that's something that DT worked on, and DT is closely tied to the BNG initiative that we have at ONF, which is BNG API especially, which is called TASN. You can take a look. There is a lot more discussion on TASN on the VOLTHA 2.6 webinar, sorry, not the VOLTHA 2.6, the SIBA RD 2.0 webinar, which I linked in here at the start of the presentation. There you can also find the contact of Mario, who is the guy that with Carmelo at ONF are mostly working on the BNG at ONF and partially also with TIP. On the BBF side, we are always looking at collaborating with the BBF. I personally have to say I don't know exactly what BBF is doing in the BNG space. I might refer you to Carmelo and Mario for answering that part. If you want, please reach out to me with your email, and I can put you in contact with the rest of the folks. There was another question which says, how about OLT PON CTL, which I imagine is control? How VOLTHA handle DBA algorithm? Which algorithms can VOLTHA implement for the shared channel of the PON? Could I propose some algorithm and deploy it in VOLTHA? At the moment, as I said, we don't share channel of the PON. So it's like one subscriber per PON connection, and it's the PON tree that goes into the transceiver, and it's so that on that part, VOLTHA doesn't really go and change that. So if you're more than welcome to look at possibly introducing some of these in VOLTHA, and we can give some thoughts offline on how it's best to be done in here. Okay, I have another question which I have to take offline because I need to delve into some of the concepts. The question is, does VOLTHA 2.7 as an AN driver use the standard OLT ONU device T data models? For example, the BBF ones. So it's a yes and a no. The device management interface that I mentioned here is based on there's a specific TR383, if I'm not mistaken, from BBF, which is the basis of this device management interface over here. And but on this side of things, the API that also exposes to provision subscribers, that is not BBF based. There are some work that plan to have a common abstraction up here that is BBF based, but I don't know the current status of that. So that's kind of an answer. Then maybe we can take it offline and have a better discussion on it. Okay. It's a great question. What is the resource difference between running OF agent directly on the device and implementing the open OLT agent? So there's a lot going on in there, because if you just take this one, the OF agent, and put it on the box, you're losing a lot of the knowledge that is put in here. you will have to not just put the OF agent on the box. You will have to put an OMCI stack on the box. You will have to put the capability for alarming, for pushing Kafka data, for pushing data to Kafka, for handling Gemports IDs and Tcons IDs. So effectively, it would not just be putting the OF agent on the box. You would have to put everything here on the box. There are boxes that are capable of doing it, and it's something that has been of interest of the operators to have this capability to take the system and put it on for example, a multi-blade chassis, which is very powerful OLT. Just could put it there. It's just that at the moment, this is better also for resiliency and HA scenarios because you deploy it onto different servers. So if one goes down, the others can handle the load. And also, you have it in the data center, which is a much more controlled environment, and you share the infrastructure. So the Kafka bus, the etcd, and ONOS is shared among multiple stacks. Could be a little bit more difficult if you have to go to the field directly with the Kafka bus, for example. Would be a little bit harder. There's time constraints over there. So that's kind of the difference. Nothing prevents you to take the stack and put it on the box, but still you would have to have a layer of translation at some point to go to the device specific APIs. I hope I answered your question over there. So another question asks if IP MPLS stack available as part of the ONF open source for the OLT in a complete network deployable form. Not exactly sure what you mean by this question. What we provide as part of the open source implementation is the capability and all the services and the code base for you to create and provision services for the subscribers on a PON network. When I say services, for example, HSIA, voice over IP, video on demand, well, we don't act as we don't have an interaction with other networks in terms of like we don't go to the act as an autonomous system with the OLT or that. I'm not sure I am exactly getting your question, but for provisioning services for the subscribers, so for me as a subscriber of Deutsche Telekom, for example, we are capable of providing IP services, connectivity to the subscriber. We don't act as an autonomous system, and we leverage the existing part of the operator's network for some parts of our deployment and some of the other and some connection to other parts of the system. Having said that, we are looking at the capability of starting MPLS pseudo wires at the OLT and terminating them somewhere else in the operator network. That's a capability we're looking at in the future. Okay, I think it's a final question and we're perfectly right on time. Any plans to support micro OLTs? That's a good question. We do actually support the Tidbit micro plug OLT. I can put you in contact with the person that has been very involved in the community from Tidbit, and that has an implementation of an adapter for their OLT, and it's capable of provisioning as we do within bigger chassis-based OLTs and pizza box OLTs. So the support is there. Obviously depends on the vendor and what their interest is, but from a VOLTHA perspective, there's no change. It doesn't matter if an OLT is capable of supporting 64 subscribers, 12 subscribers, or thousands of subscribers because it's a much bigger OLT. So yeah, support microplug OLTs is there. Okay. I think that was the last question. We're right on time at the top of the hour. So thanks a lot for joining. As I mentioned before, we will share the slides that you see here in an email that you will receive from Denise. I want to personally thank you for staying and listening to me for this whole hour. It's much appreciated. Let me thank you again, our community, for the great contribution. And yet again, drop me an email, especially those of you who have asked questions and I don't know your email because it's not written here. Please do drop me a line, especially if I didn't answer your question properly as you wanted, and I'll be happy to have a discussion with you on this. Looking forward to any contribution that you guys will make on in the platform. Thanks, everybody. Take care. Bye bye.